let's take a look at what's called the location principle. And so we can use the location principle to help you find real zeros of polynomial functions, real zeros. Okay, basically what that is our x-intercepts of functions. So the location principle, it says if f is a polynomial function, a and b are two real numbers such that f of a is less than 0 and f of b is greater than 0, then f has at least one real zero between a and b. Okay, so f of a is less than 0. Basically, that's just saying when it is negative. Okay, so if we have this graph here, and let's see, and we have an a and a b, and we're just looking at this interval. Let me just draw this a little bit nicer here. Okay, so at f of a, and that's a negative value, okay, this is a and this is b, that if this is negative and this is positive, the y value is negative and the y value is positive here, it will have to pass through the x-axis in order to finish the graph is what we're saying. So if there is a point that is in the negative, there's a point in the positive, then there has to be one real zero. It is guaranteed. Now, on the other side, if you said that f of a is a negative value and f of b is a negative value, then it's not guaranteed that there will be a real zero or there will be an x-intercept. You could have something like this. You could have something that goes up. You could have just a straight line, right? There's no guarantee that there will be a zero in that spot. So that's basically what the location principle is telling us. So to use this principle to locate real zeros of a polynomial function, find a value a in which the polynomial function is negative, where it's negative, and then another value b at which the function is positive. Then when you find one of them that is negative, one that's positive, you can conclude that the function has at least one real zero between those points a and b. This is what it's telling you. Now, another important characteristic we want to look at, what I want to focus on, is our turning points. Okay, so our turning points. Another important characteristic of graphs of polynomial functions is that they have turning points. Turning points. Corresponding to what's called a local maximum, and minimum values. Local maximum and local minimum values. The y-coordinate of a turning point is a local max, or maximum, I'll just put local max here, of the function when the point is higher than all the other points. The y-coordinate of a turning point is a local minimum, local min, of the function when the point is lower than all nearby points. The turning points of a graph that help determine the intervals for which a function is increasing or decreasing. Okay, so it helps us determine where the function is increasing or decreasing. Okay, so if I take a look at a graph, let me just kind of draw one here for you so you can see it. Okay, and let me draw, so there's our coordinate plane, and let me draw a function. like this. Okay, so certain things that we know. We would say, for example, that this point here, that would be a local maximum. It's higher than all the other points around it. Okay, so local max. Then the point at the bottom here would then be our local minimum point. You could have several local maximums and local minimum points. And then you could tell. So at that local max, to the left of that local maximum point, here, we know the function is increasing, right? Function is increasing. Same thing after this local minimum, we know the function is also increasing. Sorry if that yellow is pretty bad. And then between here, we know that the function is decreasing. Okay, so just to kind of go over those concepts about increasing and decreasing. So in the next next video, we're going to talk about absolute maximum and absolute minimums.